Uh, Good day, ladies and gentlemen. So we will be doing some activities on analytical geometry. So this is a paper from June 2017, Eastern Cape. So I'm going to show you how do you answer questions in the analytical geometry. So now we read the information given information carefully, and we try to deduce information from the given information. So now they're saying in the diagram below, so now we can see the diagram, no problem. They're saying P with coordinates 5 and 8. So here is P, no problem, we can see it. Now Q with coordinates 1 and N. So here's the coordinate, we can see it, no problem. And R, which has the coordinates 9 to 16. So they're saying are the points in the Cartesian plane, and we can see that they are on the Cartesian plane, no problem, we cannot complain. They're saying points on the Cartesian plane that form the vertices. By vertices, they're referring to the corners of the circle. If you say, as you can see, P is a corner, Q is a corner, and R it's a corner. So they're called vertices of a triangle. So the vertices of a triangle, they're saying no information yet, no highlight, no need to highlight. We just highlighted the coordinates and then we saw them in the sketch. So they're saying M, which is this point, which has the coordinates 5 is to 2, is the midpoint. Yeah, there they talking. So midpoint. So it means this M is the midpoint. That means it's in the middle of QR. And we said in that part, when they talk about the midpoint, the formula that we have to make use of is this one. Sorry, x2 divided by 2, and then ym equal y1 plus y2 over 2. So this is for the midpoint, because they talked about the midpoint. So now we know we are going to use this formula. Okay, we go through the sketch, we know what is going on. Okay, no problem. If you want, you can make substitutions here and see what you can find even before going to the questions. So now, but let's go to the questions. The first question is, show that, okay, we missed something here. Now let's put information in our diagram. So now, because I see we have alpha, we have beta, and then we have theta. So now alpha, beta, and theta, they are angles. So what we need to emphasize is alpha the angle of inclination, is beta the angle of inclination, and it's theta the angle of inclination. Remember, we said an angle of inclination, it's measured from x-axis, which is here, and then to a line. So that means alpha is an angle of inclination. So what if it's an inclination? Therefore, we can use the formula, the gradient of that line equal tan of alpha. So now it's going to be the gradient of which line? The gradient of QR. So the gradient of QR. So now at least we know something. If a question say calculate alpha, we will use the same formula. And now let's check beta. What is beta? Let's check if it's an inclination. It's measured from x-axis to a line. So is beta an inclination? Yes, it's an inclination. So that means to find beta, we can use the formula m equal tan of which angle? Tan of beta. So now is the gradient of which line? Because beta is an inclination to line PQ. So it has to be the gradient of line PQ. No problem. So now let's look at theta. You see, theta is not an inclination, but using geometry and analytical methods, we can find the angle, that angle. Remember, if an angle is not an angle of inclination, it's either we can find it by opposite angles of a triangle, opposite angles and sum of angles of a triangle and exterior angle of a triangle. So now we need to check whether we use exterior, opposite, or we use sum to manipulate theta, to be able to find theta. So now, okay, let's try to put information again. They gave us the midpoint. So now, what is 5? That is our xm. And then what is 2? That is our ym. So if 5 is xm and if 2 is ym, then x1 and x2 has to be the surrounding points. So q1, q here, the value of x of q, we can name it to be x1, and then n to be y1, and then with r can be x, or since we have x1 here, we can have x2 and then y2. Why am I naming? Because if a question comes and then we have to calculate the midpoint, and then we will just substitute without hesitation. So now they're saying the first question, which is 2 marks, show that n is equal to -2. So now let's check, where do we find n? Where we just named here x1 and y1, where there is n, and we just name x1 and x2, there is 6, and then we just name xm and ym, and there is 2. Are you aware, if you look at this row, we have 6, we have 2, and then we have n. So that means we can use the midpoint formula to find n. So now let's set up our formula, but look at the coordinate, where m is a y coordinate. So that means we have to use this one. So ym equal y1 plus y2 all over 2. So now, what is our ym? The y value of the midpoint. That's 2. Thank you. 2 equal, then what is your y1? Naming helps when it comes to substitutions. Because we have named, we just substitute things. So what is our y1? That is n, plus what is our y2? That is 6 all over 2. And then we can solve for n. So over 1, and then we cross multiply. So n plus 1 times 1, n plus 6 times 1, that is n plus 6 equal, and then 2 times 2, that is 4. So we have, if we take 6 to the other side, we will have n equal 4 minus 6, and therefore n will be minus 2. So easy 2 marks. Easy 2 marks. So the first question, they said show that n is -2. And then from the information that we have, or we've collected on the midpoint, we found that, okay, y1 is n, and then we have ym, and then we have y2. So the only unknown is the value of n. Or even if you have substituted into the formula, you are going to see that the only unknown in the second one was going to be n, and then you can just substitute, you can just solve for n. So now going to the second question. The second question is, if L, okay, let me go to the second question. I don't want to, okay. They're saying if L is the midpoint of PR, so that means, let's go and put that L. So L is the midpoint of PR. Let's put L somewhere there. So there's our L. So of PR, show that LM, this was a 6 marks question. They're saying show that LM is equal to half of a PQ. So now, you relax, you remain calm, and you try to come up with a solution. They gave you the answer. They're saying if L is the midpoint, so that means this is where you start. You need to find the midpoint of PR. So now, using the same formula here, we can use xm equal x1 plus x2 divided by 2. And on the other side, we can use ym equal y1 plus y2 divided by 2. So now make substitutions. They told us that L is the midpoint. So now let's go ahead and solve for that. Find the coordinates of that midpoint. So now we have PR. They're saying it's a midpoint of PR. So since we have x2, y2, that one can be x1, y1. Since we have 1 and 2, as long as we have 1 and 2. So now what's going to be our x? Oh, I love making this mistake. So this is x2. So now what is our xm? Xm we know is the x value of the midpoint. That's 5. So we will have 5 equal. And then what is our x1? Our x1, we go back to the diagram. Our x1, because we're focusing on PR, our x1 was 5. So we have 5 plus, what is our x2? We go back to the diagram. There's our x2, that is 9. So we have 5 plus 9 all over. Oh, sorry, I made a mistake here by saying 5. Remember, because it's xm, the x value of the midpoint is the same coordinate of, is the coordinate of L, and then we don't have it, so we just put xm. Sorry, I made a mistake. Xm, simply because we don't have the x value of the midpoint of PR, so hence we substitute xm, hence we put xm there, hence we put xm. Sorry for that mistake. So now over, this is over 2. So now xm is going to be, we go to our calculator, don't use your head, use your calculator. So that's 7. So that means the x coordinate of L, it's 7. So now let's go ahead and calculate the y coordinate. So now ym, we don't have it. So what is our y1? Go back to the diagram. Our y1 is 8. So we have 8 plus, and then what is our y2? Y2 there, so that is 6. So we have 8 plus 6 divided by 2. So the y value of the midpoint will be 8 plus 6. Sorry, 8 plus 6 divided by 2. That's 7. So therefore, the coordinates of L are 7 and 7. Nice. That's where we start. So now, remember, we need to show that LM, which is they're talking about the length, LM is equal to half of PQ. So now, even as we need to find the length of PQ, we need to find the length of PQ. Since we have the coordinates of L, we can find the length of LM. So now let's go ahead and find the length of LM. So now LM equal the square root. We're going to use the distance formula. So that's going to be x2 minus x1 squared plus y2 minus y1 squared. So it's better to write the coordinates. Remember, the coordinates of L are 7. The coordinates of L is 7 is to 7. And then the coordinates of M is 5 is to 2. So now I said you will decide. You make this one x1, y1. You make that one x2, y2. So it's up to you which one do you want, or you can swap them. So now let's go ahead and substitute into our formula. That's the length of LM. So what is our x2? Our x2 is 5. So we will have 5 minus, what is our x1? That's 7. So we just take the values that we have named. So now what is our y2? Is 2. Following the formula, we just substitute those values. So all squared. And then we put the whole thing in the calculator. So the square root of 5 minus 7 squared plus 2 minus 7 squared. So we get the square root of 29. Nice. We're going somewhere. So now we have the length of LM, which is the square root of 29. So that means PQ, LM has to be half of PQ. We have to get at least something that is either half or something that show us the relationship between LM and PQ. So LM is half of PQ. So that means PQ must be twice LM. So we must get 2 something, 2 square root of 29. So now we can go ahead and calculate the length of PQ. So now PQ equal the square root. I'm not going to write the formula. We just substitute from this one. So I'm just going to write the coordinates. So the coordinates of P are 5:8, and then the coordinates of Q are, remember, that was 1 and -2 because they said we must prove it. So 1:2. So now let's go ahead and substitute. Let's name first. Say x1, y1, x2, y2. No problem. So now let's go ahead and substitute. From the formula, it's x2. What is our x2? That's 1 minus. And then what is our x1? Our x1 is 5. All squared plus what is our y2? According to the formula, our y2 is -2 minus y1. What is our y1? It's 8. All squared. And then we are going to put the whole thing in our calculator. So we have the square root of 1 minus 5 squared plus -2 minus 8. Oh, sorry, minus 8 squared. So you see, we get 2 square root of 29. So now, do you see the relationship between the two values, this one and that one? I said LM has to be twice LM has to be twice PQ. LM has to be half of PQ. From the values that we got, we got LM as square root of 29, and then we got PQ as square root of 2 times square root of 29. So that therefore LM is half of PQ. Even if you were to substitute those values here, square root of 29 equal 1/2. For PQ, you substitute 2 square root of 29. Then the 2 will cancel, and then left hand side will be equal right hand side. So that's how you prove these things when you are given length. If they give you length, go ahead and calculate the length, or calculate whatever length that they are talking about. So now, that was a 6 marks question. So we have another question, which is 1.2.2. 1.2.2. They say we need to show that LM is parallel to PQ. That is a 3 marks question. So remember, parallel lines. What do you know about parallel lines? If they say you need to show that 2 lines are parallel, and then this is what you have to know. You know, parallel lines, they have the same gradient. So to prove that, we have to find the gradient of each line. So we will find the gradient of LM on that side, and then find the gradient of PQ on that side. So now we have the coordinates of L. Previously, the coordinates of L was going back to the sketch. Yes, the coordinates of L, as you can see here, was 7:7. So now let's go ahead and try to substitute. So we have 7:7, and then the coordinates of M, we found them, we got them, they were given 5:2. So we go ahead and put them there, 5:2, and then the coordinates of P, what are the coordinates of P? 5:8. So we have 5:8. Then Q, what are the coordinates of Q? 1:2. So that's 1:2. And then it's up to you. You naming it's up to you. You can make this one to be x1, y1, This one x2, y2. The same here, x1, y1, x2, y2, or vice versa. It does not matter. Then using the gradient formula, divided by x2 minus x1. So we're going to use the gradient formula for both points, for both lines. So now the gradient of LM, the formula is y2. What is y2 on LM? It's 2. So we have 2 minus, what is our y1? Then our y1 is 7 because we did name. So 2 minus 7 divided by, what is our x2? Our x2 is 5 because we did name. So we have 5 minus, and then what is your x1? Our x1 is 7 because we did name. So therefore, the gradient of LM equal. Put the whole thing in the calculator. So 2 minus 7 divided by 5 minus 7. So the gradient is 5 over 2. So we're going to do the same thing with PQ. So the gradient of L of PQ equal. We use the same formula. What is our y2 on PQ side? Our y2 is negative 2. So we will have negative 2 minus. And then the formula is y2, which is negative 2 minus y1. What is our y1? It's 8. Divided by, then x2. Our x2 is 1 minus x1. That's 5. Therefore, the gradient of PQ equal. So now we put that in a calculator. Minus 2 minus 8. Then 1 minus 5. What's the answer? 5 over 2. Beautiful. So we get the same answer. Therefore, PQ is parallel to LM. Why are you saying that? Because the gradient of LM equal the gradient of PQ. So that's how you snatch marks under analytical geometry. So we have the question, the third question. The question says, determine the equation of a line perpendicular to QR passing through QM. So determine the equation of a line that is perpendicular to QR. So now let's go ahead and try to draw a sketch on the diagram that we had. So here is our sketch. So the question say, determine the equation of a line perpendicular to QR. So where is QR? Here is QR. And they're saying it passes through M, through the point M. So that means something that's like this. Sorry. So the angle here, that's 90, because they said that line is perpendicular to QR. So now, can we find the equation, the gradient of that line? They talk about perpendicular. So this is what you must start with. Once they talk about perpendicular, I think it's imperative to start with. Let me put this page here. I think it's imperative to start with. Okay, the question is 1.3. They want the equation of a line perpendicular to QR. So they want the equation of this line which is perpendicular to QR. We can find the gradient of that line. So because we know the gradient of that line multiplied by the gradient of QR must be -1. The gradient of that line multiplied by the gradient of QR must give us -1 because we know they are perpendicular. So we can find the gradient of QR first and take the reciprocal of that. So that's going to be y2 minus y1 divided by x2 minus x1. So now let's go to the diagram and see. So you see we have Q and R. We have named them. So we're going to have to substitute them. So what is our y2? That's 6. So we have 6 minus, and then what is our y1? That's n, and n was -2. So that is -2 divided by, and then what is our x2? Our x2 is 9, so we have 9 minus, and then what is our x1? It's 1. So for accuracy, we put the whole thing in the calculator. Remember, you can't find equation without gradient, so you start with the gradient. So 6 minus 2 divided by 9 minus 1. So the gradient of QR is 1. Guys, remember, I said you take the multiplicative inverse of this one, but you must put negative, or you can substitute this one, substitute it here, and then it will be clear. So the gradient of that line multiplied by, what is the gradient of QR? It's 1. It's equals to -1. So 1 multiplied by this, that's just the gradient of a line equal -1. So that's where we start. We have the equation, we have the gradient of that line. So secondly, we need a point that lies on this line. And they told you, they say it passes through the point M. So that means we can use the coordinates M, which is 5:2, to find the equation using y minus y1 equal m into x minus x1. So remember x1 and y1, the coordinates here, x1, y1, the point that we choose. So that's going to be y minus, what is y1? Is 2. And then the gradient, -1 minus, and then x1, that's 5. And then we manipulate. So -1 times x, that's -x. -1 times -5, that's +5. And then we transpose that -2 to the other side. That will be +2. So y will be -x plus 7. So that's the equation of that line that they're talking about. Important. I read the equation. They said determine the equation of a line that is perpendicular to QR. I went to my sketch and draw an imaginary line, because they said that line passes through M, and the angle there is 90, since they said they're perpendicular. And then I used the fact that if the lines are perpendicular, the gradient 1 multiplied by gradient 2 is -1. So I used it here to find the coordinate, the gradient of QR, and then used the equation of a straight line. So now they're saying if S is a point such that PQRS is a parallelogram, determine the coordinates of S. So 1.4, guys, I'm leaving it to you. And then if it is also given that the points P, Q, T are collinear, calculate the value of Y. Remember what I said with the collinear points, write the gradient. So you are also going to do 1.5. I'm just going to give you a hint. If they say points are collinear, start with the gradient of PQ equal the gradient of QT equal the gradient of PT. So this is what you must do, what you must write first, and then expand them like y2 minus y1 divided by x2 minus x1. Find the gradient of each. Find the gradient of each. And then in the end, you will take 2. And make sure that when you take 2, let's say you pick QT and PQ, you pick this part, you must make sure that the only unknown, is y, so you can be able to solve it. And then going to the last question, which is 1.6. I want to show you 1.6, guys. 1.6 says 1.6. They are saying determine the values of the angles alpha, beta, and theta. So I'm only going to determine 1 or 2, and then the rest you will determine them. So now let's determine the value of theta. Let's look at theta. What did we say in the start? We said to find theta, we can use that formula. So we can just say the gradient of QR equal tan of alpha. So now, what is the gradient of QR? Nice thing. Look at this. We know the gradient of QR. Here is the gradient of QR. It's 1. So we will have 1 equal tan of alpha. And then therefore, alpha will be using what you know, arctan of 1. Therefore, alpha will be 45 degrees. We know arctan of 1, it's 45 degrees. So finding alpha, not that difficult. And then let's go to our sketch again. What did we say in the start about beta? We said beta is an inclination, so we can use the formula to find that beta. So go ahead, and then m of pq equal tan of beta. So now what is the gradient of pq? We need the gradient of pq. Let's go ahead and calculate the gradient of pq. So we know the gradient formula is, or where is it? It's y2. Okay, here is the formula. It's y2 minus y1 divided by x2 minus x1. So you calculate the gradient of beta, and then you try to solve that and send it in the comment section. I want to see what's going to be your approach